beautiful, elusive, mysterious. These three adjectives are often used to describe one of physics' most massive conundrums, the black hole. Relatively speaking, it has only recently been discovered, yet the awe surrounding its traits and overall strange nature is stronger than ever. During the duration of this video, I, your narrator, Bianca Anderson, yep, that's me, will describe the black hole and some of the physics behind it. Just as a warning, I am by no means an astrophysicist. I, however, am very interested in topics such as these, so please maintain a level of objectivity as you watch this. Now, I bet some of you are wondering, what in the world is a black hole? A black hole is a hole in space and time, an object that is so incredibly dense and has such a strong gravitational pull that nothing, not even light, can escape its steps. This may sound like something out of a science fiction film, but the existence of black holes is not an impossibility. In fact, the law of gravity and the theory of general relativity both allude to black holes existing. Now, let's first dive into the law of gravity. As we have learned in the past, the great Isaac Newton came up with the law of gravity during the 17th century. Using observations made of the natural world, Isaac Newton was able to deduct that all objects were attracted to one another by a force called gravity. Gravity is indeed one of the least powerful forces known to man. However, it does have the ability to leave its mark, so to say, on objects that are not necessarily close to one another. Because of this trait, gravity has a way of aiding in the shaping of this universe and the way the objects in it behave. Einstein, the great 20th century scientist, built upon his predecessors and stated that gravity was an attractive force because heavier objects such as planets and moons warped the fabric of space and time, causing a curvature which led to their attractive tendencies. What Einstein came up with is known as the theory of general relativity. After this video is over, I should do a simple demonstration to simulate this theory. Now that we have an idea about how some of this basics of black holes works, let's talk about how one is formed. A black hole is formed when a massive star succumbs to gravity and collapses on itself. In order for a black hole to form, the candidate star has to be very massive. That's right, folks. Our sun is nowhere near the size required for a black hole to form upon the death of a star. A star the size of, say, VV Cephei A, which is a red hypergiant, could form a black hole. The reason why a star ends up collapsing on itself is because the amount of nuclear fusion taking place in the star's core does not produce enough energy to override the star's gravity. Nuclear fusion is when atomic nuclei fuse together to form a heavier nucleus, releasing energy in the process. When this process slows down or stops, the sun's gravity becomes too much and the core can no longer sustain it. What follows is one of the most powerful explosions known to man, the supernova, which can result in the remnants of the star's core collapsing on itself, forming a black hole. Once a black hole is formed, it has an event horizon. This is not a solid object, but marks the point at which an object can never leave the black hole. At a distance, a black hole's gravity is the same as any star. Once you get closer to it is when its magnitude becomes evident. This is because all of the mass of the dead star has been condensed into an infinitely small point. An interesting fact is that if our sun was replaced by a black hole, the Earth would still rotate in its normal orbit. Many may wonder how scientists can detect an object that doesn't emit light. Though not an easy task, scientists can observe the orbits of other stars and objects to see if a black hole is the cause for anything out of the ordinary. Also, black holes can lead to quasars, which are black holes that, while in the process of eating another star, emit powerful beams of light as a result of the victim star's gases. Although there are so many mysteries surrounding black holes, scientists are working to uncover them. Many scientists believe that at the center of every large galaxy lies a black hole, which acts as an aid to help galaxies maintain their shape. This means that there could be a black hole right in our very own Milky Way galaxy. So next time you're in your backyard and pondering about what you can see, like the stars and the planets and the moons, contemplate what you can't see, those massive objects that lurk in the dark, remaining ever so elusive, the black hole.